Well, hello, computer scientists and seekers of general truths. Let us do this example here of breadth first search, or BFS, and we want to show both the queue and the search tree. So I'm going to draw my search tree over here, and then my queue will be down here. And then, so we're going to start the queue over on this side. Okay, so this is the start of the queue, or the front. Let me use correct terminology here. This would be the front of the queue over here. All right. Okay, so let's just get right to it, and then we'll kind of back up and look a little bit more of how breadth first search really works. And this is a little bit tedious, but it's necessary practice for us to really internalize the process. So we're going to start from H. So we're going to start here. And we want to go to J. So we want to find our way eventually to J, which is all the way over here. All right. And so first thing I'm going to do is I'm going to take H and I'm going to put it onto the queue. So H currently is at the front of the queue, and H will be our starting point here for our search tree, our root as we call it in graph theory terminology. And then we're going to take all the neighbors of H and put it onto the search tree, so that would be I and also B. Now, it doesn't really matter in this example because every edge has a cost of 1, which node we put on first. But just for the purpose of being consistent, when selecting neighbors, push them onto the queue in alphabetical order. So we are going to place, and I'll put it on the search tree first. So we can go to B, or we could go to I. Okay. So we're popping the front, we're removing H from the front of the queue, and then we're placing B and I onto the queue. Okay, so the front of the queue is over here. Then from there, we're going to pop the front of the queue, which is B, and then we're going to add the neighbors of B onto the queue. And so my choices here are A, R, C. I can also go to I, and I can also go to H, except that those two nodes have already been exhausted. We've already put them on the queue, so we're not going to re-add them onto the queue. All right, so we're going to attach these to extend these from B in alphabetical order. So that would be A, and then C, and then R. So A, C, and then R. Excuse me. All right. Continuing with the process, we have not made our way to J yet, so we remove the front of the queue, which is I. And if you notice here, every time we remove something from the front of the queue, we're essentially saying, I'm going to start searching from that node. So from I, where can I go? Well, I could go to B, but that node has already been used, so I can only go next to this node right here, which is Q. Okay, so we're going to add Q on here, and we're going to put Q onto the queue, onto our search queue. All right, and then let's continue with this process. Let's alternate some colors here. Let's make things a little bit more, maybe a little bit easier to follow. So I'm going to remove A from the front of the queue, so which means I'm going to start searching from A. Right? Now, where can I go from A? Well, I could go to P, I could go to S, I could go to D, and I could go to W. Okay, and we're going to add them on here in alphabetical order. So D comes first. P comes next, then S, then W. Okay, so on here we add D, P, S, W. All right. And we have not made it to J yet, so we will continue our search. Next, we are going to remove C from the front of the queue. Whatever's at the front, we're going to remove it. So we're going to remove C, and we're going to look at node C, and let's see where we can go. We could go to P, but that's already been used. We can go to Q, but we've already gone there. So there's nothing to add for C. And when you see that, when we look at this search tree and there's nothing to add, basically this is a dead end, right? There's nowhere else to search from. All right, so we continue. We're going to cross off R next here in the front of the queue. So that means we go to node R and we search from there. We could go to Q here, but we've already gone there. Or we could also go to E. Okay, that's a new place. We could also go to P, but we've been there. We can go to S, so we've been there already. So here, from R, we go to E. That means we add E onto the queue. Okay. After E, pop the front, which happens to be the letter Q. So that's this spot right here. And where can we really go? We've already been to C. We've already been to R. The only other place we can go to now is T. So from Q, we could go to T. And add T onto the queue. Okay. After that, let us cross D off of the front of the queue. So from D, we could go to T. We've been there. We can go to E. We've been there. We can go to F, and we can also go to J. So we can go to F, and we can also go to J. All right. Let's put it on here in alphabetical order. F comes first, and then J. Now at this point, we can stop searching. We found our destination. Our destination here is J. We could also continue we can also keep going down this queue until we cross them all off, until we reach J, until J makes it all the way to the front. But we don't need to do that because we already know here from our example that J is our destination, and we can stop right here. So now let's retrace our steps and figure out what is the exact path to get from H to J. And using the search tree here will help us. So from H, we go to B. And then from B, we go to A. And then from A, we go to D. And then from D, we go to J. So our precise path that we should walk down here is as follows. From H to B, from B to A, from A to D, from D to J. Okay, that big yellow annoying picture highlight there is the shortest path that we can go down, and then we can count here. This has a cost of 1, 2, 3, 4. Okay. Now this example is simple because these edges are unweighted. It costs exactly the same no matter which edge you go down to. We'll revisit this problem a little bit later on when it actually causes a difference, when the cost is something besides 1. Let's say each of these edges is some different number. We'll revisit that case a little bit later on. But hopefully this example illustrates how to perform a breadth first search. And we've done this with an extra condition here that we're just going to put them on here in alphabetical order, just for just as a convention, so that we can, if everybody does the same thing, we get the exact same path. As always, thank you for watching. Ask for help when you need clarification, and have a wonderful day.